Hey, sixth graders, we are on lesson 1.4 and we are going to be able to compare different air temperatures of different locations. And by the end of this lesson, you should be able to better understand and describe why different areas or different locations have different air temperatures. So let's go ahead and take a look. In the last lesson, let's see if I can do this without sound. Okay, in the last lesson, we figured out that air temperature is how hot or how cold something is, and really that's about how much energy is in that air. Then we know that the energy from the sun is transferred to the surface. We learned this when we heated up those rocks with the lamp. And then some of that energy is transferred back to the air above the surface. And we are going to keep going here. Okay, so today we're going to explain how that energy from the sun can warm the air. So we know that the energy warms the air by warming up the surface, and then that surface transfers some of that energy back to the air. But it does not explain why the temperature is different in different locations. For example, we started off by looking at Los Angeles, and it's 60 degrees in Los Angeles. And we looked at Colombia, where it is 53 degrees, and we also looked at Pakistan, where it is 46 degrees, compared to Minnesota, where it's about 20 degrees. So why is it if the sun warms up all of this land, we know that the sun is warming up this land, sending energy to the surface, why is it that it's a different temperature in each of these places? We are going to use a map that looks like this, called the Global Air Temperature Map, to help us better understand. When we start looking at a map like this, we need to think about how can we read this map. So we have a temperature down here at the bottom. It says negative 50 degrees, and up here it says 30 degrees Celsius, and that's going to help us understand how to read this map. So the negative 50 degrees Celsius is these areas down here where it is white. And the 30 degrees Celsius areas are these red areas in the middle. And then everything in between tells us what temperature it is. So if we have something that's yellow on the map, it's going to be around negative 10 degrees on average here. So we have 10 degrees, and then we have blue, purple, and light blue. All right, so we need to look at that degrees Celsius bar to better understand and read these maps. We just looked at the colors. And so we have an equator on our map, and if you don't remember what the equator is, it's an invisible line that kind of divides our globe, our world, in half. And as you can see, the equator falls right in the middle of this red zone. So everything directly above it is very dark red. Everything directly below it is dark red. So we know that it's 30 degrees Celsius in that area. It's warmer. And as we move away from the equator, it starts to get cooler. So as we move down the scale, it starts to get cooler. And as we move down here. So if we flipped this bar right here, if we flipped it vertically, let's go back. If we flipped it vertically, it would read the exact same, right? We would see the red, the yellow, the blue, the dark blue, the purple, the white. So let's go ahead and take a look at the next thing. We have another kind of map that tells us about how much energy we're getting from the sun based on this equator. So we can see the equator is running down the middle again, and down here it says the areas with the dark orange are getting the most energy from the sun, whereas the places with the white are getting the least energy from the sun. And again, if we flipped this up, we would see that starting here and going up, or starting at the equator and going down, we would have most energy, a little bit energy as it gets less, and then we have our white. So we have orange, orange, yellow, yellow, tan, tan, and white. And we get the least energy from the sun down here and the most energy from the sun up here. So these two maps really help us understand temperature and energy and how we can talk about them together. So we could look at a map like this and we could say that the areas in the middle have the warmest temperature, and they have the most energy from the sun. The places at the top have the lowest temperature, right? Lowest temperature, and the least energy from the sun. So the big vocab word for this unit is going to be latitude, and that's talking about the distance of a place that is north or south, so north or south of the Earth's equator. So any distance that goes like this, and we're going to zoom in and look at a picture of the equator right now. So if we look at this picture of the equator, we can see that there are these little imaginary lines that go above and below it, north and south of the equator, and they each have a number that goes with them. And they go by 20s, so we can read it just like we read a ruler or a thermometer. And we can see that as we go north, every 20 degrees north of the equator, which is 0 degrees, we have another invisible latitude line, or an imaginary latitude line. And this helps us understand the world, and it helps us read our maps a little bit better. So our equator is at 0 degrees latitude. Okay, so we have higher temperatures at the equator, and we have higher energy at the equator, so hopefully that will help us understand what happens to our locations that are not near the equator. So our places at the top are going to have our least amount of energy. They're going to have our cooler temperatures, and as well as our places near the south or the bottom of our map. So we can look at these different locations and understand how they are next to the equator, and that's going to help us understand how much energy they're getting from the sun, and why different places on the map, why different locations on our map, on our world, have different air temperatures, and how that latitude really affects the air temperature. It says that means location's latitude affects the air temperature. So we really want to know what is the effect of that air temperature. So if we go back to this little video, we can see here, I'll leave the music on, that we can kind of wrap up the second part of this video. So the energy is transferred to the Earth's surface. That energy is then transferred back to this air above the surface. And then we can see that the closer a location is to the equator, the more energy it's going to get from the sun. And therefore, a location's air temperature is affected by its distance from the equator. So how far it is from the equator. All right, 6th graders, I hope that you have a wonderful time learning about this and adding some notes to your notebook. And remember, today is a great day to learn. Happy learning!